Okay, hi everybody. Right, for today we are going to look at how the light rays, right, how they pass through a convex lens. So you can see from here, right, the laser from the emitter, they actually pass through the convex lens, after which they come together or they converge, okay, onto a point along the principal axis, okay, as you can see from here. But how do we explain for this? Okay, this is what we are going to do next. Okay, so let me draw here. These are the rays that as they pass through the lens, they meet or converge at a point along the principal axis. Okay, so how do we explain for that? Let's look at the upper portion of the lens, right? Okay, first let me enlarge it. Okay, and I have a ray that incident on the front of the lens. So what happened to it as the light ray comes from the less dense air into the denser lens? So let's draw a tangent at the point of incidence here. Following that, we draw a normal at the point of incidence. This is the normal. So as you have learned, right, from refraction, as the lights come from the less dense air into the denser convex lens, what will happen to it? Okay, how does it refract? You actually bend towards the normal. Okay, right, having the angle of incidence to be larger than the angle of refraction. Okay, following that, okay, how do we see the light that comes out from the lens into the air as it emerges out? Okay, at this point, we draw the tangent again, after which we draw the perpendicular normal at the same point of incidence. So what happened? Okay, so the refracted ray that's inside the lens, right, as it comes out from the lens and into the air, which is less dense, it actually bends away from the normal, like this. Okay, so this is what happened as the light comes in from the air on one side through the lens and out of the lens. And here you have a larger angle of emergence. All right, next, okay, we will draw the principal axis. Okay, for principal axis, it will just pass through the lens without any bending at all, right? Okay, so this is the principal focus. Okay, so this is for the upper part, okay, of the lens, how the light rays comes in from one side and emerges out from the other side. And now we look at the lower portion of the lens. Okay, same as before, let's draw an incident ray that just touches one side of the lens. Then we again, at the point of incidence here, we draw the tangent, okay, for this curved surface. Following that, the perpendicular normal. Okay, same as before, from a lesser dense region into a denser region, okay, which is the lens, we draw the refracted ray that is nearer to the normal. Right, and on the other side, okay, before it emerges out, you draw again the tangent followed by the normal. Okay, so again with the angle of incidence here, which is larger than the angle of refraction, right? So on the other side, okay, as it emerges out of the lens into the air, it bends away from the normal. Okay, as we can see here, with a larger angle of emergence. So from here, right, as you can see, okay, from the top, right, the light ray enters the lens, bend towards the normal and away from the normal as it hits the focal point on the principal axis. Following that, okay, we have the lower part where the light ray comes in and hits the lens, travels through the lens, which bends towards the normal, and as it emerges out, okay, it bends away from the normal. Okay, so that explains how the light rays, as they incident on the lens and emerges out of the lens and meet at the common point, the principal focus. Okay, thank you.